Welcome back to lecture 4. Today we're going to talk about device mesh. So what is a device mesh? Device mesh is a way to represent your GPU topology as a tensor. So here we have 3 different device meshes. The first one, we have 8 GPUs and we just lay them out as a single tensor, as a single dimension. The second one, we lay it out 2 by 4, and then the third one, we lay it out 2 by 2 by 2. And the reason why we represent it this way is so that in the same way that you can slice into a tensor, you can slice into a device mesh to express your parallelism. And to understand that, let's look at some code. So here we have a previous example, but we've done a few things. So one, we've updated our device mesh to be 2 by 2 by 2. We've updated our tensors to now be size 8 by 8. And then critically here, we've updated our placements so that instead of just a single dimension placement, we actually have a 3-dimensional placement. And when you read this, it might seem a little confusing, but the way to think about it is that the dimensionality of this will be the same as the dimensionality of your device mesh. And each element represents what is stored on that dimension of the device mesh. So in the case of X, what we're saying is the first dimension of the device mesh will store a shard of the first dimension of local X. And then the same with the second dimension, and the same with the third dimension. And so what this means in practice is that effectively every single GPU will store a shard of X. In contrast here, we're saying the first 2 dimensions will store shards of the column dimension of Y, but the third dimension we will replicate. So what does this mean? This basically means that in the case of X, every single GPU will store 1/8 of the overall set, and in the case of Y, the first 4 GPUs, in this case, let's say 1, 2, 5, 6, will store shards, and then GPU 3, 4, 7, 8 will store a replica of those shards. And to see this in action, if we run this code, we'll generate these TL parses. And if we look at the joint graph, we'll see indeed for X, it's 8 by 1 because it's sharded by columns. And so you can see that there's 8 shards. But for Y, it's 8 by 2, indicating that there's 4 shards, which is exactly what we expect because we expect there to only be 4 shards that are then replicated one time. So hopefully this gives a good overview of what a device mesh is. In subsequent lectures, we're actually going to utilize this quite a bit to understand how D-tensors use device mesh to do all the magic it does behind the scenes.